Okay, so the we're going to look at the trigonometry questions, as that was the next that was requested. Like I said, all these will eventually be totally cleaned up, but what I need to do first is we're just going to go through these lives and we're just going to work through them, and then I will go and clean them all up and write them all out for you guys. But this is just in case you've got any assessments after the bank holiday. I'll try get through all the Edexcel ones before the end of Monday, but they will be at very, very random times. It's sort of, I have a gap just now for an hour. So if I pull up the topic 5 questions, here we go. So the first question that we have here, we've got a shape, we've got a sector, we've got arc length in radians. So straight away, you're going to think of your formulas. So the formulas you should know is that we have the area of a sector, which is a half r squared theta, where theta has to be in radians. The length of an arc, which is r theta, again, where it has to be in radians. And then if we want a segment, so remember a segment is like, so if you've got a circle, a sector is your piece of pizza, that's your arc. Now, if somebody cuts it in like a very strange way, that bit's your segment. So your segment is your sector minus a triangle. But the triangle normally has the radius r as well. And so we get a half r squared theta minus a half r squared sine theta. Now, we might not need all of these, but those are general formulas whenever we see something like this. So we've got a shape. We've been given the arc length. So we've been given the arc length, and we've got AOD is 12 centimeters. Okay, so if we want to work out the OD, which is going to be our radius, we can use this formula here, where we know the length of it is 3. So we know 3 equals r times 0.4. So therefore, r equals 3 divided by 0.4, which gives us 7.5 centimeters, which equals OD. And then we want the area of the shaded segment. So that's the other side. So first of all, we're going to say, okay, so it's a different circle. We're looking for this length here, but we've already worked out that that bit here is 7.5. So we can do 12 minus 7.5, and that's going to give us our radius for our new segment. And we can also find out the angle, because we know that, all right, so we've got 4.5 here, and we know that angles on a straight line are 180 degrees or pi degrees. So therefore this angle here, which I'm just going to call x, is going to be pi minus 0.4. Okay, so the area of a sector, using that first formula, is a half times r squared times theta, which is pi minus 0.4. Now, if you leave it all and put it all together in your calculator, you're less likely to make errors where you copy it down. And when I type that into my calculator, I get 27.8, and it's an area, and it's told us it's centimeters, so centimeters squared. Okay. Right, next question. Let's scroll up. Okay, question 2. Some A-level students were given the following question. 2 attempts are shown below. I think something happened a bit strange with this. You can't show that yet. Identify an error made by student A. Okay, so cos theta equals 2 sine theta. Sine divided by cos is tan. And we can see that what the student has done is they've brought the sine onto that side. Cos divided by sine is not tan. So you'll have to say they have incorrectly said tan theta equals cos over sine, but it should be tan theta equals sine over cos. Okay, student B gives theta equals minus 20 as one of the answers, to cos theta equals 2 sine theta. Explain why this answer is incorrect. Okay, so to figure out, we could always put it back in. So you can say, well, if I substitute it back in, cos of minus 26.6, you can plug into your calculator, is not equal to 2 sine of minus 26.6. So can't be a solution. And explain how it arose. Well, whenever you square something, it's not an invalid way to calculate it, but you have to always check it. So you can say the incorrect answer arose by the introducing of squaring. So by the fact that they've squared in order to come to a solution. Right, so the next one. Given that theta is small and in radians, show that the equation can be written as. Okay, so in your formula book, let me just grab mine, tell you what page it's on. So hopefully you're all getting formula books in your assessment as well. So on page 6 of your formula book, you're given the following small angle approximations. You're told sine theta is approximately theta, cos theta is approximately 1 minus theta squared over 2, and tan theta is approximately theta. So that's what you're given. So all you're doing, and you can use these when theta is as small and in radians. So you're just going to substitute that in. Wherever you've got a cos, I'm going to replace the cos with 1 minus theta squared over 2 minus sine a half theta. So instead of theta, I've got a half theta. So that's going to be just a half theta. And tan theta is just 2 tan theta is just going to be 2 theta equals 11 over 10. We don't want anything on the bottom. So the easiest thing to do here is I would, before I even try sort it out, is multiply everything by 10. So I get 10 minus 5 theta squared minus 5 theta plus 20 theta equals 11. And then I'm going to put everything onto, well, effectively move it onto the right-hand side to make it positive. So I get 5 theta squared. I'm going to get plus 5 minus 20, so minus 15 theta, 11 minus 10, plus 1 is approximately 0, which is what I was trying to do. The solutions of the equation are 0.068, 2.932, correct to 3 decimal places, comment on the validity. So you're going to say this one is valid. So you'd say theta equals 0.068 is valid because remember, it's got to be valid when theta is small. So you're saying it's valid because theta is small. And theta equals 2.932 is not valid because theta is large. So if you think about it, pi, which is 3 point something, is 180 degrees. So 2.9 is quite a large angle, okay? And they usually, even if you get a different question, this is a very typical question that they might ask in this form. Okay, next question. Okay. The depth of the water is modeled by where t is the number of minutes after midnight. A boat enters the harbour at 6:30 and it takes 2 hours to load. Okay, so maybe that's relevant later. The boat requires a depth of at least 3.8 before it can leave the harbour. Find the depth when it enters the harbour. Okay, so when it enters the harbour, it's at 6:30 a.m. Now, as far as t is the number of hours after midnight, 6:30 a.m. is 6.5 hours after midnight. So you're just going to substitute in d equals 5 plus 2 sine 30 times 6.5. And I plug that into my calculator. I get 4.48 meters. Now, if I remember correctly from this exam paper, you had to write the meters to get the mark. I know it's only 1 mark, but you had to write the meters. And then it says, find to the nearest minute the earliest time the boat can leave the harbour. So the boat needs to leave the harbour when it's at least 3.8 and at least 2 hours after 6:30. Okay, so we're going to bear those two things in mind. So we're going to have 3.8 equals 5 plus 2 sine 30t. Right, let's make sine 30t the subject of the formula. So we're going to get 3.8 minus 5 divided by 2, which gives you minus 0.6. Inverse sine, so shift sine of 0.6 gives you minus 36.86. Now remember sine, the rule to get the next one, I mean, you might use cast diagrams, but the rule to get the next one is always to divide, so sine is always 180 minus x. Okay, so 180 minus, which gives me 216.86. Right, and if I do 216.86 and I divide it by 30, what I get is 7.22. Now that's not 2 hours after 6:30. So I'm going to add 360, because remember sine repeats every 360 to e to the 36.86, and I get another solution. So I'm going to get 360, 36.86. So the next one along, which is 323.14, I now can divide by 30. I know that one, the first one doesn't give me a correct answer, that doesn't either. Divide by 30 gives me 10.77. Now 10.77 is the time like per hour. You can use there's a button on your calculator that looks like this. I don't know whether you've come across it. And that'll change it into time. Otherwise, you can just take 0.77 and times it by 60 to get the number of minutes. And we end up with 10:46 a.m. Okay, so I hope that makes sense. You want to make sure you're doing it at least the 2 hours after 6:30. So I remember that being quite a big mistake that a lot of people made, but they only lost a mark. So, you know, it's not the end of the world. Right, question 5. Solve the equation 5 sine 2 theta equals 9 tan theta. Okay, so when you've got a mixture of different things, the best and easiest way to do things is to change everything into sines and coses. Now you should know your trig identities. So you should recognize that sine 2 theta is 2 sine theta cos theta. And you should also know that tan theta from AS is sine theta over cos theta. So we're going to replace everything. We end up with 5, 2 sine theta cos theta equals 9 over sine theta cos theta. I'm going to multiply up the cos theta, and that's going to give me 10 sine theta cos squared theta equals 9 sine theta. Now, the important thing to do here is you can't just cancel out your sine theta from both sides. So what you're going to do is you're going to move everything onto one side, and that's going to give you 10 sine theta cos squared theta minus 9 sine theta equals 0. You can take sine theta outside a bracket, leaving you at 10 cos squared theta minus 9 equals 0. Now either sine theta equals 0 or cos squared theta equals 9/10, which means that cos theta equals the square root of 9/10 positive, or cos theta equals minus the square root of 9/10. And then for each of these three situations, you're going to solve between minus 180 and 180. And you will end up with the inverse sine of 0. Well, you know, for your sine graph, or just, you know, using your calculator, you've got 0, Does it include 180? Yeah, it does. It's going to be 0 at 180 and minus 180 and at 0. So we're going to have our solutions for this one here are going to give us 0, 180 and minus 180. If I take shift cos of the square root of 9/10, I get 18.43. So I'm going to have 18 point, how many decimal places? It just wants to 1, 4. And cos is 360 minus, but that's obviously not going to be in the range. And we also get plus and minus. So minus 18.4. Inverse cos of minus 9/10 gives you 161.6. And your other solution is minus 161.6. All right, so you end up with 4, 5, 6, 7 values. So that's quite a lot, but the bit that a lot of students get wrong is eliminating the sine theta. You can't just cancel it out without considering it to be a solution. Okay, deduce the smallest positive solution to the equation. Okay, so if we match them up, we can see. So first of all, we're going to say which of the numbers. Okay, I can see what they've done. Sorry, I was just reading the question. So if we match it up, we can say that instead of theta, we've got x minus 25. So x minus 25 can equal any of these, right? But we want the smallest positive one. So if we made it equal to 0, it would be 25. If 180 is obviously going to give us something bigger, minus 180 is not going to give us a positive solution. 18.4 is going to give us bigger than 0. We could make it equal to minus 18.4. So therefore, our smallest positive solution is going to be 6.6. So you've got to say which one of those solution matches. Okay, question 6. Right. Figure 2 shows a sketch. State the coordinates of P. All right, so if we think of what our normal cos graph looks like. So for our cos graph, we've got a graph like this, at 90, 180, 270, and that's minus 1. Okay, so what are we doing here? Whatever's outside the bracket affects the y. So the y is affected by 5. The y's do exactly what you expect them to. You're multiplying the y coordinate by 5. So instead of minus 1, my y coordinate is going to be minus 5. My x coordinates are the things inside the bracket, and x's always do the wrong thing. So instead of minusing 30, we're adding 30. So instead of 180, that becomes 210. Okay. Part B, solve the equation equals 4 sine x, giving your answers to 1 decimal place. Right, so there's a couple of ways to do this. I think the easiest way is use your identity and open this out. So in your formula book on page 6 as well, you get given cos A plus minus B equals cos A, cos B, minus plus sine A, sine B. And that just means the sign swap. So if there's a minus there, you're going to have a plus. So let's open it out. We end up with 5 cos x cos 30. Instead of minus, we're going to use a plus. 5 sine x sine 30. And that's equal to 4 sine x. Okay. So if I have a look at that, what have I got? Cos 30, okay. So what I could do is put all my coses on one side and move all my sines to the other side. So I've got 5 cos x cos 30, which is just a number, equals 4 sine x minus 5 sine x sine 30. If I take sine x outside a bracket, I get 4 minus 5 sine 30. And on this side, if I think about it as cosec outside the bracket, I've got 5 cos 30. I know that sine over cos is tan. So then tan x is the same as 5. I know these are all numbers, but if you leave it all like this, you're less likely, and then plug it into your calculator in one go, you're less likely to make an error as you copy it down. So I've got 5 cos 30 divided by 4 minus 5 sine 30. When I plug that into my calculator, it tells me tan x is 5 root 3 over 3. I do inverse tan of that, and I get 70.9, and tan is the easy one. It repeats every 180, so you just keep adding 180 to get through your range. So we get one more, so 250.9. And I've got my 2 solutions. I hope that makes sense. So I've opened it out using the formula. I've put all the causes on one side, all the sines on one side, and divided it to make it tan. Right, deduce giving reasons the number of roots. Let me do, so we can see there's 2 roots, and so I'm just going to clear it so I've got some space. Right, the number of roots of the equation, okay, okay, I can see what they've done here. So they've given us a range, which is 10 times the range. So in one set of range, if we had, well, we saw we had 2 solutions here. So in one lot of the range, we've got 2 solutions. If it was just x, we'd get times 10, so we'd get 20 solutions. But because we've got 2x, we're squishing the whole graph, so we're going to get double those solutions. So we're going to end up with 40 solutions. So you would say, because there are 10 cycles of 360, and x is 2x, so we'll be double the roots. So 4 roots in every 360, something like that. I know it's an explanation. I'm not very good at that, but normally we're quite generous when we mark exam papers on explanations, as long as it makes sense. Okay, question 7. Show that, right, so that cosec x minus sine x is equivalent to cosec theta cot theta. If in doubt, and if you can't see it and you can't think of an obvious trig identity, generally the easiest way to do these is to transfer everything back into sines and causes. So we say cosec, well, we look at the third letter, which is an S. So we know it's 1 over sine theta minus sine theta. Okay, so that's not so useful yet, but we're going to make that into one fraction. So left-hand side equals, I'm going to put it over sine theta, and we get 1 minus sine squared theta. Now, hopefully you recognize that's the same as cos squared theta. And then we've got cos theta, we could separate it out. It's cos theta times cos theta over sine theta, and then we've got our answer. Cot theta, which is our right-hand side. And then we've got hence or otherwise solve. Now this threw a lot of students in the exam. It's not actually difficult, it's easier than it looks, but it did, but I can see why it may have. So we're going to say, well, this looks like this. So we're going to replace that side with cos x, cot x. Okay. 3x minus 50. Right. So the same thing, we can't just cancel out without considering when it equals 0. So if we were to cancel those cos x's, the only reason we can is because we're going to think of, well, we've got to think about when cos x equals 0 in order to cancel them out. Okay, and we know that will give us 90, so we got one solution. And then we can make the cot x equal to cot 3x minus 50. So x equals 3x minus 50. So we end up with 2x equals 50, but we have to remember it's cot, and cot works exactly the same way as tan. So it repeats every 180. So we're going to say 50 plus 180 at this point, which gives us 230. And then we can divide them both by 2. And our three final solutions are 25 and 115. Okay, so the classic mistake here was to forget the cos x equals 0, and then also to forget the 115. But hopefully you recognize the connection between A and B. Okay, question 8. All right, oops. Right. We've got some circles here. The circles meet at A and B, AOB, so AOB, and what we're told that's 0.635 radians. And we want to show that. Okay, fine. So the first thing we're going to have to find is where the two meet. So if we can figure out where these meet, we've just got ourselves a triangle, hopefully. So if I solve them simultaneously, I've got x squared plus y squared equals 100. And so that tells me, let me rearrange it, for y squared equals 100 minus x squared. And I'm going to substitute that into the second circle. And that's going to give me x minus 15 squared equals, plus 100 minus x squared equals 40. Open out the brackets. Minus 30x. Plus 225 plus 100 minus x squared equals 40. And we end up with 30x. So that cancels, move those that side. We're going to get 40, 325 minus 40. So 285. So x equals 9.5. Okay, so we got our x coordinate of 9.5, which is that coordinate there. That's going to be 9.5. And our y coordinates are going to be plus and minus the same thing. We can plug it into the first one. And we're going to get y equals 100 minus 9.5 squared, square root answer. And we get plus and minus root 39 over 2. Okay, so now we're going to find that angle. So if I think of this triangle, I'm just going to take half of it. So from A, O, and I'm just going to call that X, to that point X. I know that this is root 39 over 2 because I've worked out that coordinate. I also know from O to A, because it's circle 1, that's 10. So therefore, I also know that this is 9.5 actually, because that's what I've calculated as well. So I can use any of those numbers and I can find this angle here. So let's use 9.5 and 10 and say cos theta SOCAS, so adjacent over hypotenuse. And that's going to be half the angle. And so I want 2 lots of that angle. So if I do inverse cos of that, make sure my calculator is in radians, 9.5 divided by 10, I get 0.31756. And then I'll say AOB equals 2 theta, which equals 2 times 0.3175, which times 2 hopefully gives me 0.635, and I've done the question. So I hope that makes sense. And then we want to find the perimeter of the shaded region, giving your answer to 1 decimal place. Okay, so the perimeter is going to be all the way around the edge of here, which will be easy because we know the length of an arc is r theta. We know that r is 10 because of the form of the circle being, that's square root of that. So we could do, and we know that this angle here is going to be 2 pi minus 0.635. So r theta equals 10 times that. That's for that black bit. Plus, we want to find out this bit here. But in order to do that, we've got to find out what the angle is for that bit over there. So first of all, we're going to have to find that angle. So if I erase all this so it's easy for you to see what I'm trying to show you. The center of the circle, so we know that's 9.5 is somewhere here, and we want to find this angle here. We know that this is root 40, and we know that this bit here must be 15, which is your x coordinate, minus 9.5, because that's the bit that we worked out before. So 15 minus 9.5, which gives us 5.5. So in order to find out our angle, we're just going to do cos theta, let's call it beta, equals 5.5 over root 40. We do inverse cos of that. So shift cos 5.5 divided by root 40. So we get 0.51, and again, that's only half. So we want to double it. So yeah, 0.5163. So let's say 2 beta, and then times that by 2. 1.032. And so we're going to do 2 pi times that, times by root 40. So root 40, 2 pi minus 1.032. I plug that all into my calculator, and the perimeter equals 89.7. I told you if it's centimeters or what it is. No. So 89.7. So I think, I know that looks a little bit of a mess, but hopefully that makes sense. So you've got your circle and your coordinate geometry being tested there as well. Okay, next question. Okay. All right. Solve the equation 4 sine x equals sec x. So we're going to change the sec into 1 over cos. So we're going to get 4 sine x equals 1 over cos x. And so we get 4 sine x cos x equals 1. And hopefully you recognize from your identity sine 2x is 2 sine x cos x. So 2 sine x cos x will equal a half. So that's sine 2x equals a half. You're going to do inverse sine of a half. So we're in radians. So shift sine of a half is going to give you pi by 6. The rule for sine is always 180 minus. So in this case, it's pi minus. So you get 5 pi by 6. Divide by 2. You get pi over 12 and 5 pi. That should be 12 over 12. Okay. Part 2, solve for 0 to 360 that equation. Right, there's a few ways to do this. And I know lots of students I know did it in different ways in the exam. Some people squared it, but they recognize what to do. But a thing that they've tested quite a lot is using the form r sine plus theta minus alpha, or sine theta or cos theta plus alpha. So hopefully you may have recognized that you could write that in the form r sine theta minus alpha. So when we open that out, we get r sine theta cos alpha. minus translates to minus. The reason I've chosen minus is there is a minus between the two of them. R cos theta sine alpha. And then we match them up. So we end up with the coefficient of sine alpha is 5. So R cos alpha equals 5. And we've got R sine alpha equals 5. So when we solve that, we square and square root to get our value of R. So R is equal to 5 squared plus 5 squared. So we end up with R being root 50. And tan alpha is sine over cos. So tan alpha is just going to be 1. So alpha is going to be 45 degrees. So we end up with root 50 sine theta minus 45 equals 2. So sine theta minus 45 equals 2 over root 50. We plug that into our calculator. So 2 divided by root 50. We've gone from degrees to radians, so don't forget to change your calculator. So inverse sine answer, and I get 16.42. Next solution is 180 minus answer, so 163.57. And then I'm going to add 45 to both of those. So plus 45. And how many decimal places? 1 decimal place. So I end up with 61.4 and 208.6. So I hope that makes sense. This comes up quite a bit in the more recent exam papers. So I'd really suggest being able to recognize in the old spec papers and a lot in your textbook papers, they say, show that blah, blah can be written as, and therefore do. That doesn't necessarily happen with the new specification. So be really careful about that. Okay, let's move on to question 10. How much time we got? Okay, we got some time. Right, so we've got cos 3a equals 4 cos cubed a minus 3 cos a. Okay, so again, we're going to use our formula book. We've got cos a plus minus b equals cos a cos b minus plus. So this is on page 6 as well, sine a sine b. So we're going to recognize cos 3a is the same as 2a plus a. So we're going to get cos 2a cos a minus sine 2a sine a. And this is where knowing your trig identities becomes really important. Cos 2a can be written as 3 different ways. So we know we can write it as cos squared a minus sine squared a, or 1 minus 2 sine squared a, or 2 cos squared a minus 1. Now, because we want our final answer all in terms of cos squareds, I'm going to choose this final version in terms of which one to use. So we're going to use 2 cos squared a minus 1 times cos a. We know sine 2a is 2 sine a cos a times sine a. So when we open that out, we get 2 cos cubed a minus cos a minus 2 sine squared a cos a. Now the only thing, so remember sine squared a is just a fancy way of writing sine a all squared. The only thing that's not in coses is this sine squared a. So we're going to replace it with 1 minus cos squared a, cos a. And when we open out that final bracket, we get 2 cos cubed a minus cos a minus 2 cos a, minus and minus give us plus 2 cos cubed a. So we've got 2 cos cubed a plus 2 cos cubed a to give us the 4 cos cubed a. We've got minus cos a minus 2 cos a, and so we've got our minus 3 cos a. So you just rewrite the answer as your final bit. And then it says hence solve. Now, whenever it says hence, that's your very unsubtle hint to use the question. So use the bit above. So we're going to replace cos 3x with this. We get 1 minus 4 cos cubed x minus 3 cos x equals sine squared, which immediately I'm going to change into 1 minus cos squared. So I've got everything in terms of coses. I'm going to move everything onto one side. Well, there's ones on both sides. So anyway, we've got minus 4 cos cubed x, those can disappear, plus 3 cos x equals minus cos squared x. Move everything onto one side. 4 cos cubed x minus cos squared x minus 3 cos x equals 0. You can literally plug this into your calculator as a cubic if you needed to. If you don't, if your calculator doesn't let you, take cos x outside the bracket. You've got 4 cos squared x minus cos x minus 3 equals 0. And then you can factorize the bracket in terms of cos. And you've got 4 cos x plus 3 and cos x minus 1. So cos x equals 0. Cos x equals minus 3/4, or cos x equals 1. And then you can do inverse cos for those 3 options and get your answers, which come out to be, well, you should know for inverse cos of 0. So you end up with, let's do shift cos of minus 3/4. Actually, let's do this one first. So x equals 90. Shift cos of minus 3/4 gives me 138.6. 138.6. And inverse cos of 1 we know is 0. We also know, because we're going down to minus 90, as well as 90, we're going to get minus 90, and those will be our 4 solutions. Okay, let's hope I have literally 5 minutes. Hopefully I can get through some of the last question for you, but this might feel rushed. If it does, I will come back and do this at the start of whatever the next set is. Okay, so question 11. Right, this is going to be, I've only got 5 minutes, so I'm going to do this very rushed and talk through it, but pause it, go through it, and see if you can do it later. And I'll try go through it again slowly at some point. So r cos theta plus alpha, I open it out using the formula. I get r cos theta cos alpha, plus means minus, so minus r sine theta sine alpha. I match my coefficients, so I get r cos alpha equals 10 and r sine alpha equals 3. I know that my r is always the square and square root of those values. So I'm going to get r is the square root of 109. Tan alpha is going to be my sine over my cos, so 3/10. And alpha is 2 decimal places in degrees, okay, so 16.70. And then I always make sure I rewrite it because I'm going to have to use it. So I'm going to rewrite it as root 109 cos theta plus 16.7. So now if I match this up to this bit here, I can see instead of theta, I've got 80t. And also I've got a plus there when ideally I need it to be a minus. So I need to take a minus outside as such. Okay. So for the moment, we don't need to worry about that. So we've got find a complete equation. Given that the initial height of the passenger, above the ground is 1 meter. So when t is 0, we know that cos of 0 is 1, whereas sine of 0 is 0. So that's going to make all of this equal to 0, this bit here, and that's going to make this equal to 1 when I put 0 in. So A, in order for it to equal 1, must be 11. So if I was to write that entire equation out, I'm going to have h equals 11 minus root 109 cos, instead of theta, I've got ATT. ATT plus 16.7. I believe that was, oh yeah, because it's minus the whole thing, and that's why you get your negative. Okay, that's fine. Hence, find the maximum height. So the maximum, well, you've got to just think, cos can be between -1 and +1. If we make all of this -1, we're going to get 11 minus minus plus root 109. If we made it +1, we'd get 11 minus. We want the maximum height, which happens when we make it into a plus. So when we make the cos bit into a minus, so we get minus minus, the whole thing becomes plus. So that gives us 21.44 meters. Find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle. So we said the maximum happened when all of this bit was equal to -1. So we're saying cos ATT plus 16.7 equals -1. So we're going to say ATT plus 16.7. Inverse cos of -1 happens at 180, but we don't want it at 180. We want the second cycle, which is 360 later, which is 540. We rearrange it for t, and we end up with 6.54. We either use 0.54 times by 60 to find the number of minutes, or we use the button on our calculator, and we get the time to be, sorry, it's decided not to let me write, and we get the time to be 6 minutes and 32 seconds. Okay, it is decided that to increase the profits, the speed of the wheel is increased. How would you adapt the equation to reflect this increase in speed? Well, the thing that's causing the speed or the number of turns is this 80. So you say you would adapt it by increasing the 80 in the formula. So apologies, that's a bit rushed. I really have to go now, but that's the trig stuff. I will try work through the rest of them, and we will eventually clean up all these videos as well.